Okay, so we are going to go on to probably questions 17 and 25. Now we'll have to determine how long these are before I actually make that decision. So at this point, we're just doing 17. All right, so which will experience a greater effective charge? The N is equal to 3 for argon or for krypton. Notice that they're the same energy level. So we're talking about the protons in the middle. 1, 2, 3. There's our N is equal to 3. In order to figure this out, we have to originally look at what the electron configurations are. So if we look at the periodic table, this is a horrible version of this, but that's okay. So I'm looking at argon and krypton. Argon is here, krypton is here. Notice that krypton's further down. Argon is 18, krypton is 36. So if I go back to the original, argon is 18 protons, while krypton is 36 protons. If I look at the electron configurations of both of these, argon is 1s2, 2s2, 2p6, 3s2, 3p6. So that N is equal to 3. That is their valence electrons here. So these are the most outside here. If I look at krypton, 1s2, 2s2, 2p6, 3s2, 3p6. Again, this is our N is equal to 3. But we're not done yet. So far, we only have 18 electrons there. So then we have 4s2, 3d10, then 4p6 to get us up to that 36. Okay, so from here, we have another shell out here for krypton. So technically, that N is equal to 3 is not krypton's valence electrons, but it is for argon. Also, argon has 18 protons in the middle, while krypton has 36 protons in the middle. That's a huge difference right there, because in theory, they're both the same amount of energy levels out, but krypton has more protons. Since it has twice as many protons there, it's going to pull it even tighter because there's going to be a bigger attraction. So the attraction from the nucleus to that N is equal to 3 is going to be larger. Technically, they're supposed to have the same amount of shielding because either way you have 8 electrons for Z effective. However, because of the fact that there's another layer outside of that, there's more shells for krypton. Krypton gets pulled in tighter for that N is equal to 3. So the question is, which one will experience the greater effective nuclear charge? It's going to be krypton because they're going to be closer to each other, which goes back into that second part of the question. So krypton will be closer for N is equal to 3, and it's going to feel the charge more. Okay, question 25. Using only the periodic table, arrange each set of atoms from largest to smallest. So you may remember this. As you go up and to the right, it gets smaller. So basically, as you get closer to helium or closer to fluorine, you're going to get smaller and smaller and smaller. So let's take a look at which elements we have. Potassium, lithium, and cesium are our first ones. So we have potassium, we have lithium, and we have cesium. It gets smaller as you go up. So if we're going from largest to smallest, cesium would be written first. So CS is bigger than potassium, which is bigger than lithium. And that has to do with the rings. The further down you go, the more rings, the more energy levels you're going to have around that nucleus. The more rings, the bigger the atom's going to be. The next set is lead, tin, and silicon. So let's take a look at where those are. So lead is right here, tin is here, silicon is here. Again, as you go up, you get smaller. So that means lead's going to be the biggest here because it's on the bottom, then tin, then silicon. And then finally, our last set is fluorine, oxygen, and nitrogen. This is the type that confuses a lot of people. So we have fluorine, oxygen, and nitrogen. People are confused by the fact that as you go to the right, it gets smaller. That's because you're in the same energy level, but there's more protons. The more and more protons there are, the more of that pull you're going to feel. Okay, it's going to pull those atoms, those electrons into that atom. So, but they're the same energy level. They're not increasing the energy levels. They're just increasing the protons in the middle. So if we're looking at fluorine, in fact, I'm going to actually draw this out. We have fluorine, oxygen, and nitrogen. Fluorine has 9 protons. Oxygen has 8 protons. And nitrogen has 7 protons. They're all in that second energy level. So notice I'm not drawing any extra rings. Either way, you're going to have 2 rings there. So since it's in that second ring, it's all going to depend on how many of the protons you have in the middle. Since fluorine has the most protons, it's going to pull it in. So nitrogen is actually the biggest here, while oxygen is the middle one, and then fluorine is the smallest. And again, it's the same energy level. It just has more protons pulling it in. We're going to do one more on this video, and that's number 27. Identify each statement as true or false. Cations are, this one, the actual original says cations are larger than their corresponding neutral atoms. This is true. Wait a minute, I'm sorry. This is false. They're actually smaller. Didn't feel right when I was saying it. I was looking at my notes. Sorry. It's false. Because cations are actually smaller. So if we have, let's say, you know what? Let's say we have sodium here. Let's say we have sodium with 11 protons. Then we have 1s2, then 2s2, 2p6, and then 3s1. That one electron's circling in that third energy level. That electron gets lost when it becomes a cation. Cats have pause. Cations are positive. So these become positive. Cations lose electrons. So not only do they get smaller because they've lost an electron, but that actually makes those protons in the middle more powerful. So instead of watching 11 electrons, now it only has to watch 10 electrons, and everything else gets sucked in because there's a greater attraction there. So following the same idea, if cations are smaller, lithium must be smaller. Li plus must be smaller than Li. That only makes sense because Li plus is the cation of Li. Now we have chlorine minus and iodine minus. Notice they're both minuses. So that means we had to compare the atoms themselves. So here's iodine. Here's chlorine. Chlorine is higher up. Iodine is further down. Because iodine is further down, that means it has more rings around it, which means that it's going to be bigger. It gets bigger as you go down. So that means iodine is actually bigger. So that means this one's false as well. Okay, so those were questions 17, 25, and 27.